Okay, so I had some spare time, so I decided to show a bit more about my X-ray setup, as some of you asked. It's done just on the spot, so it's not really professional. Got everything on the floor with cables everywhere, and you might hear a bunch of school children outside, so you'll have to excuse me for that. But anyways, here's the X-ray tube hooked up with some LED behind it, and here's the power supply I'm using. It's an old CRT TV. You can see that the anode has been ripped out, which I did, of course, so I could connect it easily to the tube. Before you do this, you need to discharge the anode when it's still stuck, which you basically do by plugging the TV in an outlet, but not turning the TV on. You then take a screwdriver, put a wire on it, a screwdriver with a rubber handle, of course. Put a wire on it, which leads to the neutral wire, which is this little wire right there. Might be different on different models, but that's mine. And then you basically shove the screwdriver underneath the rubber cup to discharge the tube. Do it quite a lot. Make sure that you're hitting the metal. And then you basically take a pair of pliers and you try to pull it out by twisting and turning. And it should go out after a few seconds of pulling. It's not too hard. And that's basically it. Then I've taken a cable in an alligator clip from the anode to the tube, and I put it on the anode side. And then I used the neutral on the TV. It's the same wire I showed here, connected to the cathode on the tube itself. And I've also turned the TV on and connected it to one of these outlets, which has a button so I can remotely control it. It's of course turned off right now. And that's mostly it. Got some LED here to shield the X-rays. The tube I'm using is an old Soviet Kenotron. It's a V1-0.15/55, I believe, rectifier tube. It seems to be probably the best tube you can use. That is not an X-ray tube for amateur X-ray setups. It works absolutely great, but it can be quite weird as it seems to emit most of the X-rays at one side rather than the other, even though it's basically the same on all the sides. I've noticed this as I only got like 3 millisievert on the other side, the leaded side, while on this side I get, up to 100, and well, 600 or 700 millisievert, which is such a huge difference. So you kind of have to try over and over again. And the tube itself also seems to have 2 cathodes inside of it, which is interesting. It can be, so you can basically plug the negative and the neutral to any of the connectors. And you basically have to try and see which one makes the most amount of X-rays. And it seems to be kind of the same no matter which one you choose. But I have one of them damaged, so I can only use I believe it's a smaller cathode in it. Anyways, that's basically it. And something to keep in mind if you're using vacuum tubes is if it glows blue, it is from air being ionized inside of it, and that means that it's not good when it comes to X-ray production, as it's not a good enough vacuum. And you also don't want there to be like a whole lead shield inside. This one uses a very thin aluminium shield, so there's basically nothing stopping the X-rays, only the like 2 keV X-rays. The TV I'm using is putting out 31 kilovolts at 1.75 milliamps. It means that the X-rays I'm getting has an energy of 31 keV and lower. Though the worst type of X-rays, which is like under 10 keV, should be hopefully stopped by the glass and the little aluminium shield. But I'm going to keep a good distance away, as this one is quite powerful and you don't want X-rays on you. The lower energy means lower dose to some extent, but it also means that a higher amount of them getting to you will be absorbed, like most of these will be absorbed by your body, rather than if you have a strong gamma source, most of them will go right through you without a lot of them being absorbed. So you want to be really careful with this, it can really hurt you. And also make sure to like discharge the anode every time you're doing something with your hands on it. Anyways, I'm going to do a few tests. Set the camera over here. Then I'm going to place this radio scan. See, put some LED maybe, so I can angle the radio scan so you might be able to see, like that. And I'll back off and turn the X-ray off. So 3, 2, 1. It's quite a lot. Let's do that with sound this time. Make sure that it does not fall. Let's back up. Do another round. 3, 2, 1. So it's quite a lot of X-rays. Don't know if you can see any flashes or not. I guess we can move the camera even closer. Maybe you might see quite a lot of flashes. I'll just pause it and put the camera in a better position. So the camera is closer to the tube now. Now you should see quite a lot of flashes if it works like it should. So I back off again and turn it on. 3, 2, 1. So I got the Eberline ASP-1 here with a 44-9 pancake probe. I got the plastic on, not because there's any contamination, just because, well, it's handy for other types of detection, like on radium. It's sometimes 10 million. It will saturate at around 700,000 counts per minute, so anything higher than that would be incorrect. But it's still an interesting thing. I haven't actually checked this before, so we'll have to see what the results are. So I'll back up again and the tube on. 1, 2, 3. Yeah, that scale doesn't move that much. As said, it saturates quite quickly. I don't know, it seems like it got to like 1 million counts, which seems to be where it stops with everything. Stops at the same amount with DP2 source or DP63 scales. Still interesting, fun to hear the screaming. I'll see if I can bring the DP2 now. I did do this test before, and the DP2 registered, I think I got to 60 R per hour, 600 millisievert. I won't put it as close this time, as I'm afraid of it arcing to the detector itself. So I'm putting a bit of a distance away, so you might not get as cool amount of radiation detected, but it should still be quite interesting. And the DP2 should be quite good actually, better than the radio scan, as it was calibrated using an X-ray machine, probably with around 150 keV. So this is quite a bit lower, but it's, you know, not too far away compared to these. Well, these. It was calibrated using cesium-137, which is even farther away, 662 keV compared to 31 keV. So I'll bring the DP2 out and probably putting on the 20 R per hour. So here's the DP2. It's placed quite close, actually. Hopefully it does not arc. Shouldn't. I've done this before. Here's the ionization chamber, which will detect the radiation. I removed the aluminium cover case, as it, believe it or not, it actually blocks the low energy X-rays quite well, even though it's so thin. But we should hopefully get some interesting results. I'll first put it on the 2 hour per hour mode, then increase to 20, and if it's needed, 200. So let's see, seems to be zeroed. I need to zero it individually for the 2 hour, maybe, because it's a bit weird. It seems to jump a bit, like that. I'll back off, turn it on. 1, 2, 3. And not scale. Put it on the 20R mode. As you can see, it jumps a lot. That's due to arcing, so every time it arcs, the current drops. Well, I think it's a voltage. And that kills the radiation for a short second. Let's see, put it to the 0. It's 20R now. Back off again. Turn it on. 1, 2, 3. Didn't get as high this time. Let's try one more time, hopefully. You can hear that it's arcing a lot in the tube. And that kills the radiation dose. It almost maxed at 20R. I said I've got it up to 60R per hour. But sadly not this time. I'll have to mess around with the connections later on. Can't right now. But it's still quite interesting. It's a very strong source of radiation. I'll show you where I'm sitting. Move the tube. Everything around it seems to get statically charged. Let's see. And I'm standing quite a distance away from the tube. Probably not enough, but it works well enough. So I'll turn it on and show you the radiation dose I'm getting. Quite high. Not too bad with these short bursts. But that's it. I don't really have much else to show you. Hopefully it was quite informative, or not too bad at least. And that's that. I'll probably make another video when my high voltage power supply arrives, 60 kilowatts, and also with the intensifier screen. But that's that. Bye.